In the previous class we have discussed about sorting technique. What are the different sorting techniques that we have, again the time complexity taken by each of the sorting technique, and again the criteria to find which is the efficient sorting technique. This we discussed. Now we are going to discuss about the bubble sort. The first sorting technique that we are learning is the bubble sort. First of all, let me take an element, let me take array, like I will take 3 2 3 4 3 2 1. I need to sort this one. So how to sort this one? In bubble sort, what we do is, and first of all, you need to know why there it is called bubble sort. Bubble sort, because in water, if there is any bubble, it will come up, right? It will come up because water is much less. That is, bubble will be filled with air, and it will have obviously less density than water, so it will come up. So how the smaller density material will come up in water, similarly the smallest element will come up here. This here. Now let us take first pass. I will explain you how, if while explaining you will get to know how what is pass and everything. First pass I am going to take, I am going to consider this element 4 3 2 1. What I am going to do is I will compare this and this. Okay, I will compare. If the first one is greater than second one, then that is not a good message for us. That means if first one is greater than second one, that means the first element is actually greater than second element. So that means you need to sort. You need to sort. So you will sort 4 3 4 2 1. You will sort that. You will swap this thing. You will swap these two things. Now I am come and compare these two. If when you compare, the 4 is greater than 2, that means the element that is above, or in array, the element which is first, which comes first, is greater than the element that comes after that element. So you need to sort that one, those element. So I will sort it, and so I will get the result as like this. Then I will again compare these for last two. Then again I need to swap, right? Because 4 is greater than 1. So this is a first pass. First pass. Now let me do the second pass. Right? As I said, bubble sort, why it is called? The lighter element will come up and the denser element will go down. Here the denser element was 4, so it will reach the down. Either you can consider it as an iron nail, which is when you throw into water, it will due to its high density, it will settle down, right? Like this, the higher density element will go down first. So this is how the sorting techniques takes place. Now let us talk about the second pass. Here in the second pass, we will consider again the result of the first pass. That is 3 2 1 4. But here some difference is there. Here difference is, fourth one you are not actually going to compare, because you know in the first pass I will definitely get a single element that is settled at the bottom. In the first pass, always a biggest element will settle at the bottom, that is for sure. In the second pass, 2 biggest element will be settled down. Like in third pass, 3 biggest element will be settled down. This will go on. Similarly, we am going to actually not take 4 into our consideration itself, because I don't need to compare lots of element. See, it will work even if I go here, like imagine, I will explain you again. Like I will compare these two things. Again, 3 is greater than 2, which is not good, so I will sort. Now I will compare these two things. Again, it is not a good thing, so I will swap and I will get this one. Now I can compare this one. I can compare. Since 3 is less than 4, we will not swap. But still, why to compare? Why to compare if we already know it is already settled at the bottom? So what I do is, I will not compare itself. I will not compare that. So I will show this as I will not compare. And then in the third pass, I will do the third pass. Where in the third pass, I will take the result from the second pass, that is 1 2 3 2 1 3 4. So I will not compare these two things again. Here I will compare these two things, and since 2 is greater than 1, I will give the result. I will swap them. Sorry, I will swap them. Then I will get the result. What the result I got is again it will show that it is already sorted, right? You got the result. That is how the sorting techniques work. If you had observed that we have done 3 passes, right? 3 passes for 4 elements, and you can take any number of any number of um, elements. Then you can see that the number of, if n is the number of elements, right? Number of elements, n is the number of elements, then there will be n minus 1 pass. Obviously there will be n minus 1 pass. Again, now let us see what is the number of swap that we have done. So here let me come down. So in the third pass, how many swap I have done? 1. Okay, 1. I will take 1 plus. Then in second pass I have done 2 comparison. I mean 2 comparison and 2 swap. Again 2 comparison and 2 swap. You can tell both the words like 2. Again in third comparison, in the first pass I have did 3 comparison. If you can see here, these are the 3 comparison in 3 swaps. So I will take it as a 3 plus 3. So I will get it as 6. So I need for n number of elements, what is the formula? Like for 4 elements, what I am getting is 3. Till 3 I am getting. For n elements, I will definitely get 1 plus 2 plus 3 and so on. Then n minus 1, that is what the number of swaps or number of comparison that we are going to do. And if you remember this, we have seen somewhere, right? This 1 plus 2 plus 3 plus and so on, n minus 1 will be equal to n into n minus 1 by 2. So these are the number of swaps or comparison that we are doing. So I am going to compute this thing. That means n square minus n by 2 I have did. Okay, n square, I am getting n square. Since I am getting n square, I can consider it can take n square amount of time. The time complexity is n square, right? N square. And previously we had discussed that bubble sort will actually take big of n square. So we have proved that it will take n big of n square time. So that's it. Now we will write a code for this, and these are the simple codes, and I'm not going to stretch much on the coding technique, because it is simple iteration like for loop, putting for loop. Now I have a imagine I have an array, and that array is again int arr. It is of the 4 size. In same example I will take, I will not change, right? I will not change. Then I will send this array. I will send this array to this function. This function is called bubble bubble sort. Okay, I will call this function. So I will pass array. Then I will pass the size of the array, right? Then here again I am going to call the function. What it returns? It returns, it should return sorted array, right? It should return sorted array. So what I'm going to send is, let me take array in the global variable. I can take this array in the global variable and make a change here. But what I'm going to do here is I'm going to send vector itself. Imagine I'm going to fill the sorted array in vector. Like, so I should return what? Vector. So I will consider a vector. Now see, vector int of int type, and I will call it as a vec, right? I will call it as a vec, and I will return, and that vec will be nothing but this one. Because again, while you are using vector, you must use the library, that is vector library. Then again here I will come and I will return what? I will return what? Vector of what? Int type. Okay, then bubble sort bubble bubble sort. Then I am going to take int array. This is array, or you can take like this. There is no problem in taking like this, but still I will take like this. Then int n, this is number of size I am going to take. So first of all, what I am going to do is for loop I will run. So as usual, for loop int I is equal to 0, I less than n, n minus 1 actually, because see 0 1 2 right? 2. Like, what is I represents here? I can represent as a passes. What will J represent in my in? Okay, I will write the code, then I will going to explain you. Then I will take a flag, lag flag. Let me make it as a 1. Then for loop I will go through, and again in J is equal to 0 and J less than n minus 1 minus I J plus plus. Then I will go inside. If this ARR of, that is ARR of J, if it is greater than ARR of J plus 1, then what you do? You need to swap. You need to swap what? Swap ARR, and ARR of ARR of J, right? ARR of J and ARR of J plus 1. You need to swap these two things. That's it. So when you are coming out this loop, if you find flag as, and you make, again, you make the flag as 0 here. Whenever you enter this thing, you make flag as, I will explain you why I took flag here. So if flag will be equal to 0, if it equal to 0, what you do is you break out of the complete this itself, this for loop itself. Then after coming here, you return me array return array, right? Array you should return. If you are returning array, then it should be ARR right here. There should be error. But what you can make is you can take a reference. I think if you take reference, then it should work. I think we don't need to return anything. So I think we don't need to use a vector at all. Let us see what happens. Void I will take. Okay, array. This array will, let me make this thing. Okay, array, then I will print, I will not take any vector. Then what I do is I will call for this function, that is bubble sort. Then I am going to print array. So for int I is equal to 0, I less than 4, I plus plus, what I do is cout AR of I. Then again you give some gap, and I will run. It should work and include vector. So vector I am not using, so I don't need this one. Then if I run, I should get 1 2 3 2 1 4. I got right 3 2 1 4. So the problem is, I think n minus 1 minus, okay, so n minus 1, till n minus 1 I am running. Okay, n minus j, again j is great. We need to swap these two things. Okay, if you observe this one, yes, the number of passes it has gone through is only 1, right? That is why we are getting all other are not sorted. Let us see whether we have did some mistake or not. So n minus 1 it will go, and if flag is 1, go through. Then what you do, if it is still 1, okay, if it is still 1, you need to break through this one. Oh, it is so much common sense here. So okay, now we have sorted. Let us see what we have done. And here I am simply sending array, and array will, whatever it will actually change, the array, the original array will change when it goes and come out of the function. It will change. Why I took vector? I thought I could push the all the elements, but I changed my mind. So array will change actually. Then why I use flag? Let us see what happens. I will copy this thing, and I will paste it here, and I will explain you how. I will take this. I don't know why I'm getting this much small. Oh my god. So this is our I couldn't move this one. Okay, now see how it works. I have an array, right? 4, I have sent 4, 3, 2, 1. So initially I'll go from I to n minus 1. That means if I is equal to 0, forget about I. Now let us focus on j and flag. Then I will come to I. Flag is 1. See, initially flag was 1. But when it goes through this one, right? This one, this swapping, well, if it is swapped, imagine I have sent, instead of 4, 3, 2, 1, I have sent 1, 2, 3, 4. Then flag will be 1. Initially flag will be 1. When j is equal to 0 to n minus 1 minus I, it will go. Means initially what it does is it will go from 0 to n minus 1. That is 3 minus I is 0. So it will go through all the steps, right? It will go through. So whenever it goes through, if error of j, example here, if it is greater than this one, you need to swap. Then only you will this if statement will become true. So imagine I have sent it already sorted array. Then this statement will not run, right? It will never run. So at the when it don't run, then flag will be set. If it don't run, then flag will be 1, right? Flag will be 1. Flag will not change to 0. And I'm going to what I'm going to write here is if flag is 0, flag is 1. That means if you are not entered this swapping if that is if statement, then it is already sorted. Why to again check for the next iteration? When it is sorted, I will break this one. Means I will break the main for loop itself. So why to compare the already sorted elements, right? So that is why I'm using flag here. So j will go from 0 to, initially j will go from 0 to n minus 1 is 4 minus 1 3 minus I, that is 0. So it will go from 0 to 3, right? 0 to 3 it will go. Then when I will become 1, right? In the next iteration I will become 1. So it will go from 0 to 2. Then 0 to 1 means what I am doing is I am preventing the comparison. I already explained. There will be only 3 comparison in the first pass, only 2 comparison in the second pass. Means I'm forgetting about this last element. So to forget that last element, I'm using I. I'm using I and I'm making minus 1. It has minus 1. J is less than n minus 1 minus I. I'm forgetting the last element. So for this process, if you have understood, like here in the first pass, I have forgotten this one, and here after second pass, I will forget 3 elements, and in the third pass, I will forget about like after if we had further passes, we would be forgetting these elements, right? For that reason, I have taken minus I here. So this is how this program works. Next, I'm going to discuss about I think insertion sort, and again let us discuss about the adaptivity, whether it is adaptable. Adaptable means if it is already sorted, will it take less amount of time? So those sorting techniques which will take less amount of time, if it is already sorted, then they are called as more adaptive. Is it more adaptive? Actually, answer is no. If I don't use flag here, if I don't use this if and flag and if statement here, then it will be simply doing its job even if it is sorted. So without flag, it is not adaptive. With flag, it is adaptive. Then let us say about stability. Stability means either it is stable, like if I pass 1, 2, 4, 3, 3, then it should not change this position. Obviously, it will not change. If you trace through this passes, you will get to know that it will not change a position. We can try that one. So I have discussed about the time complexity involved here. Then all the criteria are covered here. So number of passes, number of comparison, number of number of swaps, number of that is it is adaptive or not, it is stable or not, that is discussed here. So next I'm going to cover insertion sort. Thank you.